Hello everybody, we're back to give you a few hints about day two. Day two is talking about predictability, like in the future can we predict how a certain relationship is going to go. One of the most important things about predicting the future is how is it changing currently, what's the rate of change. So the way we do that is we find the change in the function value, how is it changing over the change in the um, input variable. So it could be like over time. So like, a population is at 3 and then a month later it's at 5, so it's growing by 2 every month or something like that. So we want to find the change in the function value over the change in the input value. And the way we find the change in something is to take the difference of the two. So what's the difference between 5 and 3? The difference between the two is a subtraction problem. You just subtract 3 from 5 and you get 2, right? So that's the difference or change between two values. So that's what we're going to do here in this example. So you take the function evaluated at one point and the input value, right? And what's the difference between the function values over the difference in the input values? And that gives you a rate of change. So the function value evaluated at negative 25, you look here and it's negative 47. And then the function value evaluated at negative 30 is negative 57. So you take the difference in negative 47 and negative 57 and you see the difference between those two values is 10. And that makes sense if you think of it on the number line, but if we just keep our signs, you have to be careful with your signs here. So the first number minus the second number, and you can put that second number in parentheses to make sure you get the sign correct, because this is negative 47 minus a minus, so it's taking away a minus, which is like doing the opposite of a negative value, so you actually add it, right? So it's positive 57 and negative 47, which is positive 10. And then also we take the difference in the input values, which was negative 25 and negative 30, so the difference in those is a positive 5. And you can see the signs how they change there. So negative and negative make a positive. So the rate of change of the function value over the input value is 2 in this case. So it's kind of like the slope of the line. Like how is it changing over the input, or sometimes you say over time if you were using time, or over x if we're using position. So it's kind of like the slope of that line. How is the function value changing? So the f of x, this is the change in f of x here, over the change in the function value x. So it's kind of like rise over run. Some people use that to describe it. So like rise over run, or change in y value over change in x value. Okay, so you compare that rate of change, and then we compare it at some other 2 points. So they compared it at negative 5 and negative 10. So the difference in those values over the difference in those values, and also got 2. So it is a constant rate of change, so you circle constant. And since it is a constant rate of change, then it is a linear function. If it's not constant, then it's not linear. So if I got like 1.5 here instead of 2, then it would be a nonlinear function. Okay, so you're going to go ahead and do the same thing. Pick 2 points and find the rate of change, and then pick another 2 points, find the rate of change, and then if it's constant, then it's linear. If it's not constant, it's nonlinear. So same thing here, but you're going to want to make your own table of values and compare the rates of change, and again there. Then you're going to watch the video on the average rate of change. So when things are nonlinear, right, then we have some average rate of change. So there's a linear part of it. We can compare the difference in those values, but maybe over here it has a different average rate of change, right? So average rate of change is just the function evaluated at one point and another point, and how is it changing between those two. Okay. Then we have a little situation here with a high school gym, and they develop a a function, or they want you to develop a function about how the temperature changes given a certain number of minutes. So is the temperature increasing at some point and then down at some point? That's what you're going to do there. Just using this information. Okay, and then you're going to explain each of these in the context of the problem. So what's the function evaluated at 30 minutes? The temperature is 5 or something like that. So look at these different representations and explain what does that mean in the context of the problem. And finishing up there with that one. And then you get to this Mathema fish population. So here's something you would probably see in a scientific journal or something like that. You have this population of fish, and over time they record what the population is, right? So month 1 there's this many, then month 2, month 3, and so on. And what you're going to do is compare, average rates of change over different intervals. So from month 1 to month 3, you would find this point right here compared to that point right here, right? So I'll just do the first one. How about, it looks like 475 is the function value at 1. So 475, and then it goes down to about 325 or something like that. So we want to represent this as it's going down, right? So it's going to be a negative number. So 325 minus 475, and then I want to compare also the interval, right? The difference between these two is 2. So it's going from, 3 minus 1, right? Month 3 minus month 1, which is 2. And this is negative, I think it's 150, right? So it has a decline of negative 75 per month, right? So it's going down. It's going approximately down 75 each month. So that's what the rate of change means. Then you'll do the same thing for months 5 and 7, 5 and 8 and 10, and then months 1 to 10. So all the way across the whole thing. So from month 1 all the way to month 10. So compare those 2 points. What's the average rate of change? And then go ahead and answer the question. How does the rate of change from month 1 to month 10 describe the decline of the Mathema fish population? Would it really tell the whole story, of how the population has declined? And you can justify your reasoning there. And then the final thing is just to write in your notebook and describe the things that you learned about rate of change.